TLT present Object-Oriented Programming course. In this course, we will explore one of the most important topics in software development, Object-Oriented Programming or OOP. We will cover what Object-Oriented Programming is and how it works, the difference between procedural programming and Object-Oriented Programming, how OOP helps developers and where we can see it in real-world applications. We will also talk about classes and objects and how these objects interact with each other. Then, we'll explain the four main pillars of OOP and the benefits of using this methodology. And finally, we will introduce Git and GitHub essential tools for version control and teamwork in software development. By the end, you will understand how OOP help organize code, improve collaboration, and build scalable applications. What is an object-oriented programming? Object-oriented programming or OOP is a programming methodology that approaches problem solving by modeling real-world entities, which we call objects. Each object combines data and the functions that operate on that data, helping developers create programs that are more organized, modular, and reusable. What makes OOP powerful is that it doesn't only represent physical things, it can also model abstract concepts like classes for mathematical computations or bank transactions. In short, OOP helps us design software that reflects how things exist and interact in real life, making programs easier to build, understand, and maintain. Procedural programming versus object-oriented programming. Let's put OOP in context by looking at the concept of programming paradigms. Paradigms are simply the different style of fundamental ways we structure our code and approach problem solving. Procedural programming organizes code into a series of instructions or steps grouped into procedures, also called function or subroutines, that are executed in a specific order. OOP allow us to build complex systems by having isolated communicating objects. On the left, you see an illustration of procedural programming. This is a top-down, step-by-step approach. You issue an instruction, then another, you read data, manipulate it with a function, and then check a conditional. The focus is purely on the sequence of operation or functions. In contrast, look at the illustration for object-oriented programming on the right. Here we build systems out of distinct separate objects that interact with each other. For example, imagine a university system. Instead of writing a long procedure to enroll a student, we have a separate student object and a separate course object. We simply tell the student object to enroll in the course object. The complexity is managed because the object communicates and handles their own data and behaviors. This is much more intuitive way to model real-world problems. Why OOP helps developers? Object-oriented programming helps developers by making software easier to design, understand, and maintain. It simplifies complex by focusing on what the program should do instead of getting lost in the details of how it does it. Because OOP is modular and reusable, developers can save time. They can build new features by reusing existing classes and extending them instead of starting from scratch. It also improves organization, security, and teamwork. Since each class is self-contained, multiple developers can work in different parts of the same program without interfering with one another. Overall, OOP helps us write cleaner, safer, and more efficient code. Where we see it, object oriented programming is everywhere in technology today. We see it in many popular programming like Java, Python, C++, Ruby, PHP, Kotlin, and Swift. All these languages are built around OOP principles. It is really the foundation of the most important programming. In mobile development, Switch is used to create apps for iPhone and iPad, while Kotlin empowers most Android applications. Both of them use OOP to organize code into smaller, reusable parts, making apps easier to update and maintain. In computer graphics, OOP also plays a big role. For example, Python NumPy library stores data in objects called endarrays. These objects can be manipulated mathematically to create shapes, animation, and visual effects that appear on your screen. And finally, in artificial intelligence, OOP helps identify complex systems like libraries like Panda and TensorFlow use objects such as data frames and models to store data, train algorithms, and make predictions efficiently. So, whether it's coding app, creating 3D visuals, or training AI model, object-oriented programming is what keeps modern technology structured, flexible, and intelligent. What is a class? A class is like a blueprint that defines what something is and what it can do. For example, here we have a student class. We can see its attributes, which describe the student like name, age, major, or GPA. Below, we have its method or action, things like a student can do like enroll in a course, drop course, update GPA, calculate average, and display an info. Once this blueprint is created, we can see it to make many different students, each with their own information but the same structure and abilities. That makes OOP powerful. It helps us organize and reuse code just like reusing a model or template in real life. So that's how a class works. It is the foundation for created object in OOP. Next, I will pass it to Alex, who will explain what an object is and what are the four main pillars of OOP.
My name is Alex, and I will be teaching you about programming objects and the four pillars of OOP. First off, objects in object-oriented programming are the actual entities created from the class blueprints. The class definition by itself doesn't allocate memory, but once you create or instantiate an object, the computer needs to reserve space in memory to store the object's data. As previously stated, each object or instance has an identity, attributes, and methods defined by its class. Attributes can be variables of any type, including constants in other objects. You typically initialize the values of an object's attributes when you first create it, giving it starting values to work with. Methods are class-exclusive functions that only objects of that class can execute. However, some OOP languages allow exceptions to this rule, which we will discuss later in this video. But first, how do objects interact? Whenever you use a variable that refers to an object, that variable points to a location in memory known as a memory address. This address points to a package of data rather than a direct value. As a result, objects don't need to directly know each other's data to work with each other. Instead, they interact using their individual methods. Knowing what methods and inputs an object will accept, as well as how it will respond to these inputs, is enough. In the example to the right, you can see that a student's one variable points to a package of data containing its attributes and methods, including its name, age, major, GPA, and an enroll course function. With these basics out of the way, we can address the four pillars object-oriented programming is built upon. The first pillar is abstraction, a technique for managing complexity. It's the process of hiding the complex inner workings of your implementations in favor of showing only what is necessary and important. This allows programmers to focus on high-level design instead of worrying about the smaller details of their work. For example, once you've defined the method, you could call a student object's enroll function without directly describing how it should roll in this course. Encapsulation, the second pillar of OOP, goes hand in hand with abstraction. It's the bundling of data with methods to operate on that data within a class. Since this inherently hides an object's data, it prevents unintended access to the object's information by forcing you to explicitly tell an object to give you its data or perform its methods. In the case of a student, this is the same as never knowing their GPA until you ask them. On a different note, inheritance, the third pillar of OOP, is when one or more child classes are made to share the attributes and methods of another parent class. Child classes may have other attributes and methods outside of the parents, which creates diversity between objects that would otherwise have the same traits and behaviors. This lets you establish entire hierarchies of classes, with higher level classes acting as overarching parents and categories of lower level classes. Some programming languages like Python allow child classes to inherit from multiple parents, while others like Java don't. This is a design choice. Having more parents means you have more data to manage. In the example below, however, we only have students as the parent class of two child classes, the undergraduates and the graduates. The last pillar of OOP, polymorphism, is closely related to inheritance. It's the term for when you have different variations or implementations of the same class, object, or method. For example, different child classes of the same parent class may execute the same method differently. Method overloading is a form of polymorphism in which you define multiple methods with the same name but different parameters, allowing objects to act differently under different contexts. Method overriding, on the other hand, redefines how a child executes its parent's methods entirely, even if it has the same number and type of parameters. To better illustrate these concepts, I'll be walking you through a brief coding example written in Python. Here at the top, you can see that I've defined a student's class with 5 attributes, and if I scroll down, 5 different methods. In Python, the inits method is used to initialize an object's attribute variables with starting values upon creating it. The method takes the argument values in these gray parameters here and passes them into the attribute variables here. Name is a string, which is effectively text, age and major are integers, and GPA is a float, which is a kind of decimal number data type. Courses is actually a base Python object known as a list, which stores multiple values at once and has its own designated methods. For the major and course list parameters, setting them equal to none allows you to instantiate a student object without providing values for these attributes. And while it might not be the best idea, you can do this to every other parameter in this method. Of course, you can also provide a default value other than none, which ensures that the object will still work properly when you decide to use it. You probably noticed that the parameter itself is in every method, and that's because Python requires you to set the first parameter as some variable that refers to the object itself rather than the class. If you were to create a function that doesn't need an object to use it, you could exclude the self parameter. A side effect of this design is that the first value you pass into an object method is actually given to the second parameter instead of the first one. The enroll course, drop course, and update GPA methods are pretty self-explanatory. Enroll course and drop course will add and remove courses from a student's courses list, and update GPA will set the student's GPA to the given value. Calculate average, on the other hand, does a little something extra. It uses what we call a for each loop to go through every course in the student's courses list, sums the grades of those courses, and then divides by the number of courses to return an average grade. If a student has no courses, the average is assumed to be 0. The display info method prints all of a student's attributes and courses in a special format. Just like the calculate average method, it uses a for each loop to go through each of the student's courses in their list and calls each course's method to display its information. And if hearing that the courses are calling methods makes you think they're objects, you would be right. Each of them has 4 different attributes, which are the course's name, the number of credit hours, the course's grade, and the instructor of that course. The show course method displays these attributes, and the update grade method changes the student's grade in a given course. Down here, you can see the 2 different child classes of the student's parent's class. Undergraduates have an additional year attribute that defines what year of college they're in, and the declare year function directly prints this year in a custom format. Graduate objects have 2 extra attributes, which are the year they graduated in and the topic of their thesis. The declare thesis method is unique to only them, and it prints out the topic of their thesis in a formatted sentence. Both child classes have str methods, which are special methods that override the original method Python will call when you print the objects using only the variable names. Instead of seeing the object's memory address, you'll see whatever you define in these methods, and for us humans, that makes printing objects to variables a lot more useful. Last but not least, this code is responsible for what you see in the terminal output below. The first 2 blocks of code are object instantiations. I created 6 different courses, a student object, an undergraduate object, and a graduate object. The values I passed into these methods are the same ones being placed into the init methods you saw earlier. Beneath these 2 code blocks are print statements and method calls, down here. The dot operators in this section tell each of the objects to share information they otherwise would not share, and the method calls down here are shared between each of the different classes. You can see that students, undergraduates, and graduates can all call the enroll course and display info methods normally without any errors. But down here, the declare year method and the declare thesis method are unique to only the undergraduates and graduates respectively. If a student were to call these different methods, it would return an error because while a child class is always going to be a member of its parent's class, a parent class object is not necessarily going to be a member of its child classes. Now I'll pass the presentation off to Colin, who will discuss Git, GitHub, and Linux basics.
Good morning, my name is Colin Fox, and today I'll be presenting GitHub and Linux basics. What is Git? Git is a free, open source distributed version control system. It tracks and manages and changes in source code and files. It was created by Linus Torvalds, the creator of the Linux kernel. It enables collaboration and keeps a full history of the product changes, and supports offline work with local repositories. When it comes to the differences between Git and GitHub, Git is a version control tool installed locally on your computer, while GitHub is a cloud-based platform hosting Git repositories. Git itself manages commits, branches, and merges, while GitHub provides collaboration tools such as pull requests, issues, and discussions. And Git can work without GitHub, but GitHub enhances team workflow. When it comes to local and remote repositories, there are very few key differences. A local repository is stored on your local computer. It is used for making and testing commits privately. A remote repository is hosted on a server or cloud service, for example, GitHub or GitLab, and allows sharing and collaboration among team members. Git also syncs your local and remote repositories through push and pull commands. From the main components. As for working directory, it is a folder containing the project files being edited. Staging area or index prepares selected changes for the next commit. And commit history records all saved changes and tracks who changed what and when. Now for branching and merging basics. Branching creates independent lines of development such as Git branch. It lets you experience without affecting the main code. See it as a test run. Merging combines changes from one branch to another. It is used to integrate completed features and encourages parallel development and safe collaboration. What is Linux? Linux is an open source operating system based in Unix. It was created by Linus Torvalds in 1991. Core part is the latest kernel. It manages hardware and processes. It is used in services, desktops, and mobile devices. It is known for its security, stability, and flexibility. It is available in many distributions, such as Ubuntu, Fedora, and Debian. For key features and commands, Linux offers a multi-user and multitasking system, a command line interface, or CLI, and a graphical user interface. It also offers file permissions and package management for security and updates. Now for basic commands. First command is pwd to show current directory, ls, which is list files, cd to change directory, mkdir to create a folder, rm to delete files, and sudo to run as administrator.
This brings us to the end of our presentation on object-oriented programming, GitHub, and Linux basics. We hope you learned something, and have a great day.